What is up, my friends? Hey, we are on page 238 and 239. Whew. As we wrap up chapter 4, guys, with lesson 4-5. One of your most favorite 7th grade phrases is coming back today, and it is part divided by whole times 100.
Yeah.
What does that mean? I don't know. But if you know what that means, then you know we're going to be doing some percents, baby.
I think we're finding percents.
Let's go. Here we go. Fire up.
What is the advantage of a two-way relative frequency table for showing relationships between sets of paired data?
Who knows?
Think about this question during the lesson.
I will. And you will too.
Hayden asked 150 parents and students about how they preferred to communicate. What percent of people polled were students who preferred email?
Percent?
The problem states that 150 people were polled.
People.
How can you use the table to verify 150 were polled?
So guys, this isn't hard. How do we know there's 150 people here? Well, we can add up the number of parents, we can add up the number of students, and then add those together. We should get 150. Or you could add all those numbers up really in any order you want. We're still going to have 150 people. Okay? All good.
Adding the frequencies in the table will give you the total number of responses. 18 plus 12 plus 18 plus 102 equals 150.
That's right.
Let's begin by making a two-way frequency table.
Okay, this looks
Total the
familiar.
columns and the rows.
Yep.
And the final total is equal to the number of people polled. 150. Next, make a two-way relative frequency table.
Okay, folks, this is where we have to be a good reader. If you can't distinguish between make a two-way table and make a two-way relative frequency table, this 4-5 lesson will be challenging, okay? When they say relative frequency, they're just talking about making a percent, okay? I want to know the relative frequency of that specific cell, right? Of parents who like email or students who like text messages, whatever, okay? So relative frequencies, we're making percents. Part divided by whole times 100 will give you that percent. If you need to write that down, do that, right? That's what they're going to do here. We have three different kinds of relative frequency tables we will make. This is the first one and the easiest one, right? We call this a total relative frequency table, right? And they're going to show us how to make that.
A relative frequency table shows ratios. Each cell shows the ratio of the number of data in a category to the total number of data items. The ratio can be expressed as a fraction, decimal, or percent.
We're going to see them as percents.
How can we turn the data in the two-way frequency table into ratios for the relative frequency table? Select your answer.
Right? So if we want to turn 18 into a percent, how do we do that? Well, part divided by whole times 100. 18 is the part. What number is the whole?
150.
100? No, Mr. Knoll.
I said 150.
Oh, he said now. You guys all, we can back the tape up. He said 150. Okay? So, yeah, we're going to, again, part divided. That's what we're dividing by whole. The whole in this case is 150. There we go. So now they're going to do that for us.
Students who use email.
Okay?
Write the ratio of the frequency, 18, to the total number of data items,
150.
150. Then multiply this fraction by 100 to express it as a percent, 12%. Write the percent, 12%, in the two-way relative frequency table.
That's it?
That's all we got to do. So, guys, repeat that for the other 8 numbers here. That's all you have to do. When we make a total relative frequency table, okay? So that's what they're going to do. All these are going to get filled in here like magic.
Divide each entry in the two-way frequency table by 150 to complete the relative frequency table.
Mm-hmm.
How is a two-way relative frequency table similar to a two-way frequency table?
Well, they're still showing us the same kind of data. Probably more useful here because percents make more sense to us than just these random numbers do. Okay, do they still add across the rows and up and down the columns? For now, they do, yes. When we have a total relative frequency, look, we can still add down the columns and add across the rows, and they still add up. Okay, that's not going to work on the next two, though. Okay, but for this one, they do.
The sum of the row percent totals must equal 100%. Similarly, the sum of the column percent totals must equal 100%. Just as the total in the frequency table must equal 150.
What about the
This is because 150 is 100% of the data set. This is a useful way to check your work when making two-way relative frequency tables.
Yes, it is.
According to Caden's survey, 12% of the people he polled were students who preferred email.
There you go. And then people, we're going to have to answer questions. Once we have these percents in here, we might answer some questions just like we did with our regular two-way tables about, hey, do more people like this or do whatever it may be, okay? So we're going to have to deal with that still. All right, so the first thing we're going to do is make our own two-way relative frequency table. And it says, Asha asked 82 classmates whether they play sports on the weekend. The results are shown in the table below. Here they are. Complete the two-way relative frequency table. Now, notice they have a 100% here, right? This indicates to me we are making a total relative frequency table. So I'm going to divide, when I think part divided by whole, the whole number will come from that cell in that two-way table over there, 82, okay? All right, so let's tackle this. I got to steal Mr. Knowles' calculator. No, you're good.
I got it ready.
No, it's all good.
I was going to help you out.
Mr. Knowles is going to help me out. You guys want him to help me out?
Yep.
I mean, it doesn't matter to me. So, guys, we will give you rounding instructions. For this one right here, we are going to round to the nearest tenth. Okay? If we forget how to round numbers, I'll just make up a number here. 25.794. Rounding to the nearest tenth. Okay? If I'm going to round to the 7, that's in the 10th spot, I look here. That 9 rounds that 7 up. So we would call this 25.8. Okay? There's a little bit of rounding review. Get that out of here. Okay, so we're going to round to the nearest tenths in here. You guys ready? Again, part divided by whole times 100 will give you what we need. So boys that said yes, part 21, whole 82. So 21, right? Part divided by the whole times 100. You guys ready? I get 25.6. Nope, we got to be a pen. 25.6. Do the same thing for girls. Part divided by whole times 100. Oh no. Mr. Knowles got a bad calculator. Zero doesn't like to work. 31.7. 31.7.
That's right.
Okay. Part divided by whole times 100. 57.3. Mr. Knowles double checking my work over there, right? Making sure I didn't do anything wrong.
You've been perfect.
Yeah, so far, boys that said no, we're 18 out of 82. So part 18 divided by the whole 82 times 100. Let me do this one. Hold on. Wait for it. 21.95. Should we round that up to 22? I think so. Okay. Keep going, guys. Again, if you want to pause this, you can. 20.7. Right here. Part divided by whole times 100. 42.7.
Almost there.
Yeah, we just got one more row to go. Again, guys, this isn't hard. This is just tedious, right? So we just have to pay attention to what we're doing. 47.6. 43 is the part. 82 hasn't changed. It's still the whole. 52.4.
Nice job.
Okay. All right. So, guys, there we go. So there's our two-way relative frequency table. This was a total and the easiest kind because when we divide, we always use, right, that same whole number. On the other two, we're going to see we don't, and they look a little bit different because they have more than just one 100%. Okay? All right, so let's make all this go away. Whew, that took forever.
Yeah.
Example 2.
Your efficiency is not good this time.
The efficiency meter is not very good. Mr. Knoll's going to start this video for me, though. You just wait, like magic. There it is.
Use the given data to make a two-way relative frequency table by rows. Begin by using the categories shown on the scoreboard to build the
Back up. Okay, be a good reader. What did they say at the end of this sentence? Okay, keyword by rows. So now it's not a two-way relative frequency table, or sometimes they'll call it a two-way relative frequency table like total. Now it's by rows. How many rows do we have?
3.
3. That means that's how many 100% you are going to get. 3. 3. All right, let's see how they make this.
All right.
Oh, no. There
the
we go.
table. The column category is home game attendance, yes or no.
Yes or no?
The row category is people polled,
Student
or faculty. The table also includes rows and columns for the totals.
There we go.
How can you calculate the row relative frequencies for the data?
Okay. Well, it's the exact same process, part divided by whole times 100, but now I'm just focused in on a row. So I don't care about the faculty row or the total row when I am dealing with students. I just want to focus, right, on that row, one at a time.
Just on that run.
Okay, so just students that said yes out of the total number of students. Then if I change rows, you change the number you divide by. I know it sounds simple, but when we start doing these, it's going to be confusing for a lot of us. So we've got to be a good reader, okay? So they're still making their relative frequencies, their percents, the exact same way, part divided by whole times 100. When we change rows, we change numbers we divide by.
Find the row relative frequencies by dividing the data in each category by the row total,
Yep.
not the table total.
Nope.
For example, 42 students attended the last home game out of a total of 68 students who were polled.
There's your part and your
The
whole.
row relative frequency for this category is 42 divided by 68, or about 61 and 0.8%.
It's a great
26 students did not attend the last home game. The row relative frequency for this category is 26 divided by 68, or 38 and 0.2%. The row relative frequency for the total is 68 divided by 68, or 100%. To calculate the row relative frequency for the faculty, divide 15 by 27 for the faculty who attended the last game,
Change rows, change
and divide
percents.
12 by 27 for the faculty who did not attend the last game. The row relative frequency for the total number of faculty is also 100%. For the row that shows the total people polled, the row relative frequencies are calculated in the same way,
Yep.
by dividing the totals for yes, 57, and for no, 38, by the total number of people polled, or 95. The row relative frequencies in the total column are always equal to 100%.
Mm-hmm. Okay.
According to the row relative frequency table, what percent of students polled attended the last home game compared to the percent of faculty polled who attended the last home game?
Okay. So same thing. We're going to make our row relative frequencies, which they did, very obvious, folks, to see the difference. We have 3 100%, right? These were in the part divided by whole. These are all the whole numbers that we're going to divide by. So when we change to a row, we change the number we're dividing by. Now we can answer questions like this once we've made this, assuming we made it right. If we compare the percent of students and faculty who attended the last game, right? Well, 61, almost 62% of students attended compared to only 55% of faculty. All right, there you go. Maybe?
As As shown by the row frequency table, 61 and 0.8% of students polled attended the last home game.
Yep.
Which is more than the 55 and 0.6% of faculty polled who attended the last home game.
Yes.
In this problem, the data you need to compare are in two different rows. Remember that when you calculate the row relative frequencies, you need to divide by the row total, not the table total.
Yep. And that's the biggest difference. And honestly, people, that's the thing we're going to struggle with the most, is making sure we divide by the right number. Okay, I have faith that all of you can find percents right, but it's, are we dividing by the right number? This one says, hey, use this two-way table to make a relative frequency table by columns. So not a total relative frequency table, not a row relative frequency table, but a column, right? So these are up, columns are up and down. Okay, we are going to still find our percents the same way, going to look a little bit different. All right, but remember, these columns are always going to have 100% in them, just like our rows did. So look, now I've got 3 100%, but they're all at the bottom of my columns. So these must be the numbers that we're dividing by. Those are the whole numbers. So when we look at 7th graders, 85 is my part. 207 whole times 100. Bam, 41%. Keep doing that. Part 122 divided by 207. Part divided by whole. Bam, 58%. Again, we know 207 out of 207 people is 100%. Shocking, I know. Okay? Same structure here for the 8th graders, right? The part changes, the whole also changes. 125 over 197 gives me my 63%, right? When you change columns, you change the number you divide by. People hear what I'm saying, okay?
I am picking up what you're putting down.
Then we can answer questions again. It says, hey, according to the relative frequency table, do 8th graders check out a greater percentage of ebooks than 7th graders? Okay? Again, find that data. Answer those questions. All right, here's our work that we have to do. How does the percent of students who chose ebooks compared to the percent of students who chose audiobooks? Okay. Did they specifically say 7th or 8th grade students?
Nope.
They just said students. So that means we want to include both of them. So does the 7th grade column do that?
No.
Does the 8th grade column do that?
No.
We got to look at the total column for that, okay? So the percent of students who chose ebooks, right here, 52%, right, chose ebooks versus 48% that chose audiobooks. So more students are choosing ebooks, right, than audiobooks, okay? Question B, is there evidence that 7th graders have a greater tendency to choose audiobooks? Okay, do we care about 8th graders now? No, nobody cares about our 8th graders in this problem. We're only focused on 7th graders. You can pretend all of this doesn't exist. Cover it up, hide it. Just focus on 7th grade here. Is there evidence that 7th graders have a greater tendency to choose audiobooks? What percent of 7th graders like audiobooks? 7th graders, audiobooks. 58, almost 60%. So yes, 7th graders have a greater tendency. If almost 60% of them are choosing audiobooks, only 40% are choosing the ebooks. So yes, 60% greater than 40%. So 7th graders do have a tendency to choose audiobooks. Okay? So guys, those are examples 1, 2, and 3. Whew, sorry, thanks for bearing with me there. I know I got a little talkative. I just get so excited about relative frequency tables and finding percents. So stay tuned. Check us out for the key concepts coming up next.